Welcome everybody with this video about mathematical induction. This is quite a difficult subject for a lot of students, so I hope I managed to clarify things in this video. Okay, let's start with some definitions. If we look at px, then that's a function, and we call this px a propositional function if the function itself turns into true or false after we replace the variable inside this function with an element from the domain. So the domain is the set of allowed values. So if we look at this px, it says x plus 2 larger 10. So if we replace this x with, for instance, the first element from the domain, it says 1 plus 2 is larger 10. Okay, we can tell that this is false. So the function gives you true or false. And so the statement inside turns into a proposition whenever I replace the x with a value. That's a propositional function. In these propositional functions, we can also talk about the truth sets. And in fact, that's just a set of values from the domain for which the propositional function gives us a true. In this case, no values from the domain turn the propositional function into true. So the truth set TP in this case is the empty set. So if we look at another functions, for instance P1, and we define this function as being x plus 9 larger 10, and we use the same domain, then the truth set of TP1 would be the elements 2 already. 2 plus 9 is larger 10, 2, 3, 4, and 5. So the truth set is just the elements coming from the domain for which the function turns into a true proposition. Okay, so we know now a little bit about propositional functions. Then we can talk about the real subject, mathematical induction. And mathematical induction is just a way of proving some propositions. So for instance, if we look at this domino stone figure, if we push the first domino, then the second will fall and the third will fall, etc. So because we can throw over the first one, the complete domino part will fall down. And in fact, this is the basic of mathematical induction. If we can prove that the first one falls, the first one is true. And we can also prove that if some element in the middle, so let's say this one, if this one falls, that then automatically the second one also falls, then of course the complete tower will fall down, will be true. So if we explain this in a more mathematical way, then let's say we have a propositional function Pn. And then this propositional function is defined on the domain natural numbers, n. So if the first domino falls, means that the first element, if we put in the value of the first element of the domain, then this proposition should become true. So that means P1, in this case, because we're talking about the natural numbers, P1 should be true. And when we choose a random k somewhere in the middle, something larger than 1, and when we assume that one is true, and if we can prove then that the next one is also true, so if one domino falls, the next one will fall as well, then of course we can prove that just by pushing the first one, the complete dominoes will fall. So every element, every value in the domain will make this proposition true. So Pn is true for every positive integer n. Okay, let's look at an example. So we have a proposition, and that says that 1 plus 2 plus 3 plus n equals a half times n plus 1, and the domain is the natural number. So step 1 is to prove that it's true for the first element. So P1 equals true. That's what we need to prove. Okay, let's try. So P1 would be, okay, then I'm quite fast finished because that's only one element, equals 1. And I should prove that this is equal to a half time 1 times 1 plus 1. Okay, so this should be a half time 1 times 2. Well, that is 1, so that's it. That's never a big deal. So to prove that the first domino is true, quite straightforward. Then the second step is to assume that somewhere in the middle we have a value for which the proposition is true. So assume that pk is true for some element in the middle. So for something larger than 1. And because we have to work with it, we give this some value a name. Let's call it k. So pk is true for some element in the middle. So that means that 1 plus 2 plus 3 plus k equals a half time k times k plus 1. So this is our assumption. So this is something we know. Okay, and then we need to prove that if we know it is true for k, then it is also true for the next one. So to prove that pk plus 1 equals true. So to prove that 1 plus 2 plus k plus 1, that's now the last element, equals a half time k plus 1. So we have to change the n in k plus 1, and then n plus 1 would become k plus 1 plus 1, so that would be k plus 2. So this is what we need to prove, that the first half, the left half, is equal to the right side. Okay, let's try to do that. So we have this assumption and we need to make a proof. Okay, we'll start. Proof. So we start on the left. So 1 plus 2 plus 3 plus k plus 1 equals. Okay, what do we know? Well, we know our assumption. So we know that this part, 1 plus 2 until and including k, equals a half time k times k plus 1. So I can change this one into a half times k times k plus 1. And then don't forget, we still have to add k plus 1. Okay, if we look at this, then we see that we have 2 times k plus 1. So I can put that outside the bracket. So I have a half times k for the first part plus 1 times k plus 1. Okay, that's nice. Okay, if we have a half time k, we can take the half also outside the bracket. So that would time a half time k. But then of course, instead of 1, I need to write 2. A half time k plus 1 is the same as a half time brackets k plus 2 times k plus 1. Okay, and if we look now at what we needed to prove, then it's exactly the same. So now, because we have reached the conclusion that when we assume it's true for pk, then we can prove it's true for pk plus 1. Also, we have shown it's true for the first one. So with the help of mathematical induction, we have proven this proposition. And then quite normally we would say quod erat demonstrandum, what we needed to prove. And by the way, on the exam, if you use these full sentences, it will give you a bonus. It's really nice to read that you really understood the mathematical induction part. Okay, let's have a look at another example. So now we have the proposition 1 plus 3 plus 5 plus 2 times n minus 1 equals n squared. And again, the domain is the natural numbers. So we have to prove, step 1, that it's true for the first element. So in this case again, for 1. So we have to prove that P1 is true. So 1, okay, that's it again. 1 equals 1 square. Check. That's it. Don't worry about it. Done. So first one, true. Step 2, and that's always the difficult one. So assume pk is true for some element in the middle. So for some k, let's give it a name again, larger than 1. So we need to assume that 1 plus 3 plus 5 plus 2 times k minus 1 equals k square. Okay, then we need to prove that it's true for the next one, so that pk plus 1 equals true. So we need to prove that 1 plus 3 plus 5 plus 2k minus 1 plus 2k plus 2, so that is 2k plus 1, 2 times k plus 1 becomes 2k plus 2 minus 1, so that becomes 2k plus 1 equals k plus 1 square. Okay, that's what we need to prove. Let's try to do that. So we have our assumption, and this is what we need to prove. So proof. So we start on the left. So 1 plus 3 plus 2k minus 1 plus 2k plus 1 equals. Use the assumption. So this first part can be changed with the help of the assumption. So that would be k squared plus 2k plus 1. Okay, well, I hope we still remember from high school that we have this one, that we can change this in k plus 1 square. Done. Okay, it's not always this simple, but sometimes in fact you really just have to write down what you need to prove, and then you're already there. So just finish with the full sentences, because we have shown that it's true for the first element, and we've shown it's true that if one element in the middle is true, the next one is true as well. Then with the help of mathematical induction, we have proven that the proposition is true for all natural numbers. Okay, so I hope you enjoyed this lecture about mathematical induction. It's one of my favorite subjects, and there will be always one exam question on this subject. But just remember the format, lots of exercises you can find on Teams, and if you have a problem with it, don't hesitate and contact me through Teams or through email. Okay, see you with the next video.